I'm Jakee Stoltz, part of the Skydio regulatory team, and thanks for taking an hour out of your day really to attend this webinar and learn more about our approach to scaling DFR through regulatory work. So I want to pause quickly on even the title here of the webinar, Summiting Mount Regulation for DFR Programs. I just want to kind of explain that analogy quick. This came to me a few months ago as a useful way to describe some of what the regulatory team does and how we help customers and kind of clear these hurdles slowly. So like climbing a mountain, the work that we're doing, it's a journey. So it's not something that's been accomplished overnight. We've been working at this for many years, and so it takes persistence and teamwork and some patience at times to kind of navigate our way through some uncharted territory on our way to the summit, so to speak. Another aspect is safety. So just like climbing a mountain, safety is really important. And so we do care a lot about aviation safety. And when we're working with customers and we're working with the FAA, we're always trying to find kind of safe ways and creative ways to accomplish the mission, but still maintain aviation safety. And then finally, from kind of a customer's perspective, if you're climbing a mountain, it does help to have an expert guide or expert guides to help you navigate this. So in that way, the regulatory team, we aim to be those expert guides for our customers to kind of help navigate this, sometimes complex path. So with that, here's the rest of the regulatory team. So we're a small but highly experienced team. And the first thing that we always want people to know is that we're actually, pilots and operators first and foremost. So, we're aviation, fans, have been for a long time. We're certificated pilots. So myself, I'm a certified flight instructor, commercial pilot, and remote pilot. Jen Player is a glider pilot, and Daniel's a remote pilot. So we've all spent, a lot of time out in the field, flying drones, flying crewed aircraft. And that gives us kind of that operational experience. So then when we're working with customers and we're building safety cases, we kind of understand like what it's like to be out in the field, what it's like to actually fly these. And then we're able to kind of translate that into FAA safety cases. We have combined, 25 plus years of experience, like I said, and we've been working at this for a long time. So we've helped big, customers, leaders that are leaders of beyond visual line of sight in their respective fields achieve success. And so we're our goal at the company really is to bring all that expertise to our customers to help them achieve this as well. All right, so we always bring this slide up. This was unveiled by the company a couple of years ago. We call it the arc of autonomy. And so just like a product team has a roadmap for how the features they're going to build kind of fit into this cohesive vision of a product, you could look at this as our kind of regulatory roadmap. And in some ways, to even go back to the analogy, these could be considered kind of those base camps that you might set up on that mountain as you're kind of climbing to the summit there. So the arc of autonomy, we have 5 stages, and we've been kind of incrementally working through these stages over the past decade, really. But we believe today that we're actually kind of firmly in stage 3. And stage 3 is characterized by remote operations. So the pilot no longer has to be physically located with the drone, kind of out in the field with a controller flying it. We're at a point now where we have over 25 customers doing advanced remote operations, and this is also without visual observers and without kind of complicated technology for airspace awareness. But the vision here really, so like that autonomous summit you kind of saw in that summiting analogy, where we're going, where we want to be at, is in a stage 5 where actually the pilot becomes optional in some ways. So for DFR, what this could look like someday, and what our goal is to perhaps have a self-dispatched drone, and that drone would dispatch based on some set of criteria, both from a mission standpoint and from an aviation safety standpoint. And so the drone would respond to a call, and then as it arrives, there would still be the ability for an officer or pilot to kind of jump into the cockpit, so to speak, and start manipulating the drone through the scene to accomplish the mission. So that's kind of our vision for this. But today, we do believe we're squarely in stage 3 already. And so just to highlight that a little bit more and kind of talk about some of the customers and con ops that we've unlocked in the past couple of years. So back in 2020, we kind of entered stage 1 with the tactical beyond visual line of sight concept. That approval was in part with a partnership with Chula Vista Police Department and Skydio. And something that we're always really proud of is when we achieve success with regulatory wins, and then that becomes scalable to other agencies. So since 2020, that tactical beyond visual line of sight concept has been issued to over 500 agencies now. And so it's kind of a very common thing now that agencies are able to do that kind of tactical work. Then in 2021, so kind of now entering into stage 3 in remote ops, BNSF received a first of its kind approval to start doing remote operations with our dock product. And so this was really like the first time for small remote drones, that a pilot was able to fly a drone completely remote. So there's no flight crew on site, there's no VO, no pilot that had to do pre-flight or anything like that. So fully remote operation. And that was based on an early concept of shielded operations, ADS-B in, and it did at that time include a non-cooperative detect and avoid sensor. But then in 2023, the pace really picked up and we started to see that repeatability and that scalability. So we had a couple wins that year. So first with Dominion Energy and NYPA, New York Power Authority, they received approvals in early 2023 to begin doing remote operations within like their power generation facilities, their substations, so their energy networks. And this was based on 50-foot shielding, so flying within 50 feet of the ground or structures, and ADS-B. So there was no extra airspace awareness sensors required. Then in middle of 2023, Southern Company received a first of its kind approval to operate to 200 foot. And this is 200-foot shielding within critical infrastructure. And then finally, in the later half of 2023, and actually just recently in 2024 here, we've unlocked a new type of operation where operations can be conducted up to 200 feet AGL, and they're not quite considered shielded anymore. It's kind of on that boundary. But in this case, just ADS-B is used in a mode C veil to maintain airspace awareness in that case. So again, we're really excited that these are now scalable. So besides the companies kind of noted on the slide here, these approvals have been issued to like over 25 different Skydio customers and just innumerable other companies and operators in the drone industry. So it's something we're really proud of. Okay, so now getting to drone as first responder, or DFR, of course, and that's kind of why everybody's here, I'm sure. So we wanted to kind of talk a little bit about how drone as first responder is done today, and it is being done. So you saw the video with Oklahoma City Police Department, but there's also numerous other agencies across the country doing drone as first responder today. And so how is that done? So it's done today with an FAA beyond visual line of sight approval and visual observers. So the approval itself is called a first responder beyond visual line of sight certificate of authorization. It's kind of a mouthful, but we just kind of collectively call it a FRBV LAS COA. And this COA, this approval, does allow for remote operations. So a pilot can now be remotely located in some kind of real-time crime center or remote operations center, anywhere other than where the drone is physically located itself. And so since the pilot is no longer able to see a drone and see the surrounding airspace, a visual observer fills that role instead. So a visual observer, they are not a remote pilot certificate. They don't have to hold a remote pilot certificate. But they do need a little bit of training on their roles and responsibilities. And they're responsible for scanning 2 miles of airspace around the drone while it's flying. So a lot of agencies will deploy these visual observers up on rooftops. There's really good sight lines generally from those, so they can see kind of in all directions and around the drone. But it doesn't have to be on a rooftop either. So it could be an officer that's on the street that still has a good view of the surrounding airspace. These approvals do allow up to 400 feet AGL operations in uncontrolled airspace, or in controlled airspace, they allow up to the FAA UAS facility map altitudes. And then finally, a really key point for COAs is that when it's necessary to safeguard human life, which a lot of drone first responder operations are, the COAs do allow for kind of minimal operations over human beings. This is a really key difference between COAs and Part 107, where under Part 107, kind of the default is that you can't operate over human beings. So COAs allow for that kind of transit operation over humans. Sort of the drone, as it's just flying to the call, it might just briefly fly over somebody, a pedestrian, or a moving vehicle, and that is allowed under these COAs. All right, and so you saw, OKCPD again. They had a goal last year of deploying docks at a state fair, and so this is a really good example of an agency that is already doing DFR today and has kind of trialed this. So the police department, they worked with us to obtain this FRVV last COA, so we kind of navigated them through that process. It took approximately 2 months from the time we kicked off the project to the time they had a signed COA in hand. So it's relatively quick. A lot of people think that this FA process takes months or years, and in some cases it does not. It can actually go quite quick like this. And this approval allowed, it was obtained early enough so that Oklahoma Police Department could deploy their docks, they could do training, they could do testing at the state fair, kind of all in advance of that. So by the time the state fair came, on day one, they were ready to go conduct DFR operations. So the state fair was a big success. As you can see here on the numbers, over 11 days, they flew 341 times. It's over once an hour. And the pilots were able to kind of be remotely located in a climate controlled facility that was kind of away from the action. So it's sterile and calm, and they can just focus on flying. And I don't think anybody would be upset about not standing on a rooftop with a controller in the Oklahoma heat. And then from a visual observer standpoint, the police department used officers that were just already kind of stationed throughout the fair. So those became the visual observers, and they were able to communicate back any aviation hazards that they saw to the pilots. And a keynote here too is that, the state fair is over, but this COA actually continues to support the operations there. So now OKCPD is, they're still looking at dock-based DFR deployments, but they're also spearheading this Patrolla DFR initiative. So with X10s in officers' trunks, the officer can bring those to a call. They can deploy the drone, so they can kind of power it on and get it ready for flight, but then they can allow a remote operator to kind of take control of that drone and fly it for the mission. So the officer kind of able to offload that pilot duty. They become the visual observers, so they can just communicate back anything that they see. But it's a new kind of DFR that we're really excited about, and that this COA supports as well. All right, so now that we've kind of talked about how DFR is done today, there's a lot of agencies that are getting tremendous value out of this already, and there's just a lot of kind of excitement about how this is going to grow and mature. And so one of the hurdles that we see on the regulatory team is this visual observer requirement. So it's not easy, and sometimes it's even untenable for an agency to pull an officer away, to just stand on a roof and scan airspace. Agencies are already kind of short-staffed as it is. And so this can be a difficult proposition. Or the alternative is that you hire a contractor to do this, but then it's a budget issue. And those aren't, budget, there's not just money laying around all the time either. So This visual observer requirement is kind of a key blocker to scalable DFR, and that's something that the regulatory team has been working on unlocking now for a year. So we're going to share here kind of our approach really to this, like how we're looking at the regulatory challenge of removing a visual observer for DFR. So our approach is leveraging kind of three key things: shielded DFR operations, Skydio autonomy, and the use of ADS-B technology. And so we'll kind of get more into these on the following slides. Okay, so first off, we have a concept called shielded DFR operations. So you heard me talk a little bit earlier about shielded operations in like a utilities context. So 50-foot shield operations or 200-foot shield operations over critical infrastructure. We worked a lot with agencies to kind of understand like what kind of altitude do you need to get the mission done? What kind of altitude could we maybe settle on that balances aviation safety and the operational capability? And we kept hearing 200 feet as kind of being that number. A lot of agencies actually limit their operations to 200 feet or below today already with visualized sight. This is often the case with units that have aviation units, so helicopters. So it's kind of a nice way to deconflict those. And so we kind of use the progress that we've been making in Department of Some waivers and kind of with the feedback from agencies, we settled on this kind of hybrid approach. So shielded DFR operations is going to be up to 200 feet AGL operations, just kind of broadly. Or we know in urban areas, there's structures above 200 feet. So when you counter those, we kind of added on that 50 feet shielded operations. So it's kind of a combination approach. And again, it really just kind of builds on that success that we've had on our waivers, and we think is a nice balance between aviation safety and operational capability. Okay, and then one thing that we did hear a lot with agencies is that flying lower, there is concern about hitting obstacles, power lines, buildings, trees, and things of that nature. So that's part of what kind of drove that you're being at a higher altitude up to 200 feet. But with Skydio autonomy, that kind of really reduces or frankly eliminates that concern for hitting obstacles at lower altitudes. So we've had daytime obstacle avoidance from the very beginning, really, but now we have nighttime obstacle avoidance with Skydio Night Sense as well. And so we think this is going to be a really powerful combination of technology that helps pilots kind of avoid obstacles, reduces their workload, and at the same time enables kind of that next wave of DFR operations without a visual observer. And this quick animation here is just a quick shot of how our X10 with Night Sense navigates through a parking lot in complete just pitch black night. And so besides obstacle avoidance, Skydio autonomy also includes other features that just support safe operations. So things like geofencing with our sites feature. That sites feature now includes a safe landing zone feature. So if the drone is unable to make it to the dock or to the landing location, it can just divert itself to a chosen spot. And so you can make sure that the drone is still landing somewhere that you know and won't damage property or hit a pedestrian, for example. And then finally, we have a new feature in the moving map where we have street overlays. And so this can kind of help manage that ground risk as well. So I talked about how COAs allow transient operations over people where you just kind of fly briefly over them. But as a pilot and just kind of making aeronautical decision-making choices, you could decide maybe to just adjust the flight path just a little bit to the right or left to fly over rooftops instead of down a street. And so features like this can kind of help you keep situational awareness of what's below the drone for safety purposes. Okay, and then finally, the third part of our approach is using ADS-B technology. So I'm sure many that are watching this are familiar with ADS-B, but just in case there are some that don't. the really quick primer is that ADS-B technology enables aircraft like this helicopter, airlines, general aviation aircraft, and so on. It enables them to broadcast their position, altitude, speed, and a bunch of other information. And this is broadcast to air traffic controllers. For their use, it's broadcast to other nearby aircraft. And this technology has actually been around a long time. I actually really love this technology back in my flying days. So when I was flight training, this was at University of North Dakota, where there's, it's not uncommon for there to be like 20, 30 aircraft or more, all flying in kind of close proximity around Grand Forks, North Dakota. And so, kind of even just from a crewed aviation standpoint, this is a huge safety feature. Like you just being able to look on a pane of glass in your cockpit and see other, my other colleagues nearby, other students, was a huge safety benefit. I also love that when I was flight instructing, just to kind of coordinate, hey, I'm going to do my maneuvers over here, and you stay over there. We'll keep separated. So this technology has been around a long time, and now we're starting to use it to keep drones from getting near crewed aircraft as well. So there's really two parts of this. So there's the ADS-B out part, and so this is the aircraft broadcasting this information. And then there's the ADS-B in part, and that is kind of Skydio's part, where we're receiving that data and displaying it in a useful way to the pilot. So just to kind of hit on each one of those a little bit more as well. So with ADS-B, in certain low altitude airspace, it's actually federally required that you broadcast this information. So this airspace doesn't cover all of the United States. So certainly there's large areas of the US at low altitude that don't have this requirement. But even in those cases, there's kind of estimates of like 80% of aircraft nowadays have this technology and are using it. But in certain airspace, like the Mode C Vales, Class Bravo airspace, and Class Charlie airspace, it's actually required. And so that percentage of people using it goes way up. And there's been recent studies even that are indicating that as many as 98% of aircraft are broadcasting in this area. And so this is kind of displayed on this graphic to the right here. So just to kind of really quickly hit that a little more. So this is San Francisco. This is just an example, but you can kind of see each one of these airspaces on this graphic. So you have the San Francisco airport kind of in the middle with their Bravo airspace, all the way down to the surface. ADS-B out is required. You can also see Sacramento and San Jose airports. Those are Charlies. Where again, all the way down to the ground, ADS-B is required. But most importantly, around the busiest airports like San Francisco, there's what's called a Mode C Vale. And this is a 30-mile ring where all aircraft inside are required to broadcast ADS-B. So these make for really great environments where drone operators can fly and use this technology to see other aircraft flying. Okay, so that's the second part of this. So Skydio began integrating ADS-B over a year ago. And we did this to enable those Part 107 waivers and the customers doing that, like Dominion, Nightbus, other company, and so on. So we added this feature to enable remote operations for those companies, and now we're bringing it to DFR as well. And so kind of the basics of how this works is there's a receiver that's integrated with Skydio Remote Flight Deck, and that's a ground-based or an onboard receiver. So with our dock products, we have a ground-based receiver. With X10, we have an onboard receiver. And so that data is brought in and it's displayed on a map view where the drone is as well. So the operator, the pilot, will see where their drone's flying, but they'll also see other aircraft flying in the area, and they'll see the position of those aircraft, the altitude and distance relative to the drone, and speeds of those aircraft. And so we do some work to kind of minimize the number of aircraft that we show to the pilot. So we filter away aircraft that are just too far away to even really be a threat or too high. We don't want to give alerts or display data for airlines flying overhead at 30,000 feet, for example. So we kind of filter it down to just present the relevant information to the operator. And then if an aircraft does get too close, and we have some alerting criteria kind of built into the system, but if an aircraft gets too close, they'll see an alert pop up. The target that is too close will turn red, and they'll see some more information about it, as kind of shown in the graphic here on the right side. And then they use that information to make a decision. So there's not an automatic maneuver, because we believe that in not all cases today, the operator actually has to maneuver. So, for example, if a helicopter just flies a half mile kind of past the operational area, but not directly over the drone, that might be something good for the operator to know. Hey, something's kind of nearby, but it doesn't necessarily necessitate a maneuver to get out of their way. So it is an operator choice, but we've kind of designed Remote Flight Deck to just make that decision, that choice, kind of as simple and easy as possible. Okay, so that's kind of the three parts to our approach of unlocking DFR without visual observers. So again, it's kind of leveraging shielded DFR operations, so flying lower to the ground. It's using Skydio autonomy to make that safe. And then it's using ADS-B technology so that operators can see where other aircraft are and give right away if necessary. And so I thought we'd kind of go one level deeper, actually, and just describe a little bit of like our rationale and kind of our thinking around how we got to this approach. So kind of just one step deeper to give everyone some insights. So the Skydio regulatory team, we really kind of consider ourselves experts in airspace awareness broadly. So both at Skydio and in our past employments, we've worked with almost every kind of detect and avoid system out there. So we have really extensive experience with this, from ADS-B technology to radars, and that's all different kinds of radars. So we've interacted with the biggest radars, like the FAA digital airport surveillance radars. Those are kind of those really big, spinning disc radars that everybody thinks of, all the way down to, the Echodynes and the Fordhams, kind of these small panel radars today. We've used the electro-optical systems. So my colleague actually used to work there for iris automation, and we've also used the acoustic systems, such as their TASA system. And so the montage on the right is just kind of some pictures of the tests that I've been personally part of over the past 8 years or so. And just to kind of give everybody an example, like one of my favorite ones, the picture in the upper left, actually, it's me and some colleagues standing in front of a General Atomics Predator. So it's a bigger drone, obviously. So just kind of a side story here. So the General Atomics, they do a lot of flying in the United States, obviously, for like training and testing and developing their system. And so they're also kind of beholden to these FAA regulations around beyond visual line of sight. And so for the longest time, the way they would do some of their training was they would have to chase this Predator with a chase plane. And in that chase plane, there would be a pilot and a visual observer. And they would follow this Predator around and basically be their eyes in the sky and communicate any aircraft that they saw back down to the pilots. And so obviously this is like incredibly inefficient, right? To have this really expensive, large drone flying around and then having another airplane following it around just so it can see. And so they approached us, the test site at the time where I was working, about how do we remove this requirement? How do we get rid of this chase plane so that we can fly truly beyond visual line of sight? So we built a concept of operation with that FAA radar. And many people may not know, but actually air traffic control doesn't use the raw data from these radars. They don't actually look at what's called primary radar. They use secondary radar that's kind of fused with transponders and other information. So we actually worked to get the raw radar data so that we could see all aircraft, not just transponder equipped ones, but also like those crop dusters and other types of aircraft that aren't equipped. And so, kind of long story short, we did all this testing, right? We had to kind of understand how the radar works, its performance, how far it can see, how low it can see, and then we had to test the display. So how is that data displayed to a pilot? how can we make that easy? And then we kind of tested the procedures, right? So if we know an aircraft's coming, what do we do? Do we descend? Do we maneuver? And we kind of ran all these encounters. And so experiences like that, and everybody on the Skydio regulatory team has those. Experiences like that have kind of driven how we viewed airspace awareness and this approach that I described. And so in the end, we actually kind of see two types of airspace awareness. It really should be kind of looked at as two different use cases that sometimes use the same technology, but have different objectives. And so if you're an agency kind of evaluating this technology, we would just ask that you kind of consider maybe two different types of use cases and how the technology needs may be different. So one type of airspace and awareness is what you might call counter UAS. So it's that need to know what's flying around things like airports and jails and special events and the White House, for example. And your objectives there are typically to detect, track, identify, is this friend or foe, and then mitigate potentially. But the second type of use case is more about beyond visual line of sight operations. So that's kind of what we were just describing. So flying without visually being able to see around the drone. And the objectives kind of start the same. So you're still trying to detect and track, what's around my drone and what's flying. But it's just slightly different and kind of nuanced in what you do after that. So now you're evaluating, is that aircraft going to fly right over me, right next to my drone or not? And then do I need to maneuver? Do I need to descend or come home or do something to give right away? And so based on kind of that understanding, the Skydio regulatory team, we're completely focused on number two. We're completely focused on enabling beyond visual line of sight operations for our customers in a safe, scalable, and effective way. And so that's kind of really what's driven that strategy then to use shielded DFR operations in ADS-B. And that's for a couple reasons. So number one, ADS-B technology relative to some of these other sensors is very inexpensive. So you can oftentimes cover, a jurisdiction with just one ADS-B receiver, or maybe two or three, but it's a relatively small number compared to for example, like a radar that might have a 5 to 7 mile range. You might need multiples of those. And so the cost kind of really ramps up from there, and you end up with a system that's at least 2 times more expensive, or orders of magnitude, sorry, two times more order of magnitude expensive than ADS-B technology. And then in the middle here, so ADS-B technology ends up being quite simple to use compared to some of these other systems. So the data from ADS-B, it comes directly from a GPS source, and oftentimes that's WAAS GPS, so it's very accurate. And so the pilot can know kind of exactly where aircraft are, how high they are, how fast they're moving, and so on. And so with that really good information, then we can display that and make things that are easy for the pilot to make decisions based on. And that's kind of compared to a system like radar, for example. There's, some companies will kind of say that their radars are really good at detecting birds and they see things like that. And we call that ground clutter with radars. So radars are actually almost like too good at seeing things. They see birds, they see semi-trucks and like cars driving down roads. They see basically anything that's like big enough to reflect that radar energy back. And so if you have all that data, now it becomes kind of challenging to actually interpret that. And so the pilot may have to interpret, is that radar target I see, is that a bird or a drone or helicopter? And that just adds a lot of workload and kind of complexity to how to use those systems compared to ADS-B. And then finally, approvability. So we're actually seeing a lot of positive trends with our approach. I described how we're already enabling this under Part 107 waivers today, these similar types of approaches. And so, we're seeing just a lot of momentum around flying lower altitudes, leveraging ADS-B technology to avoid aircraft. And that's kind of compared to, again, some of these non-cooperative sensors where, there have been approvals, certainly, but they've tended to be a little bit more kind of one-off and not necessarily scalable. And we just haven't quite seen yet that point, that tipping point where the FAA is willing to approve these widely. So again, just kind of more reasons why our approach has kind of been geared the way it has been. So one question here is, how does Skydio assist agencies in navigating like these programs? Or another way to say it maybe is like, how do you help agencies kind of navigate through this and climb that mountain? So we do it a couple ways, but we do obviously kind of informational things like this, webinars. We also have a lot of one-on-one conversations with agencies where we can kind of deep dive this and look at it relative to an agency's specific area and goals. And we do offer a service actually around helping agencies pursue these approvals as well. And so that service, kind of at a high level, it's roughly 4 steps. So we would do a kickoff with the agency, and that's where we're like looking at the jurisdiction, the airspace. We're kind of really looking at the details, the goals of the program, where we might deploy docks, for example. And then the regulatory team, we go off and develop an FAA request package for the agency. So we put together some kind of technical documents that describe the safety case, the risk assessment, the safety features of the system, and so on. And then we review that with the agency and help them submit it to the FAA. And then finally, we're there, as the FAA is reviewing that, we're there to help answer questions if there are any, and then even once it's approved, too, we're helping the agency kind of interpret their COA, answer questions if they have any on that. So that's kind of a quick high-level overview of like how we're helping agencies navigate through this today. Okay, we have another question here. Are observers looking out for planes, helicopters, or other things? Yeah, so the visual observer's job, since the pilot is not there anymore to kind of see their drone and then scan that airspace around it to see if there's hazards, that becomes the visual observer's job. So they're looking for low-flying aircraft. That could be helicopters, airplanes. It's not so prevalent with DFR, but I'll kind of speak broadly to like crop dusters if it's more of a rural area that they're flying in. So the observer is kind of scanning the airspace for those, and if they see one of those things flying around, helicopter, they do need to kind of make a decision, like, is this helicopter, does it appear to kind of be just flying at my drone, at the drone, or is it just way off in the distance and it's not getting closer, it's not converging. But it's their responsibility to communicate that to the pilot then. Hey, I see a helicopter, it's off to your north, or hey, there's a helicopter coming inbound, and recommend you descend immediately. So it's their job to look for that and then communicate that to the pilot. What models of Skydio drones are recommended for DFR use? So today, so really both our X2 and our X10. Our X10 is really purpose-built for this, so we certainly would recommend that one. But as you saw, like in the OKC PD video, agencies are using X2 today. They're using it in both like their patrol ed initiatives, but they're also starting to do some DFR with it with our X2 dock product. So I think what we want to just get across is, you don't have to wait necessarily. Like DFR can be conducted today with X2. It can be conducted today with X10, and it's only going to get better as our products continue to evolve and we get closer to that next generation dock as well, which we're really excited about. And that. One more here. With AR street overlay, can you add custom labels to buildings? I'm actually not sure about that question, but I think what we'll do with that one is take it and follow up afterwards. So we'll get our product team on that, and we're always looking for feedback. So if it's not something we do today, I'm sure the feedback team will be product team will be taking notes on that. So we'll get back on that one. So I think that's actually the last question. So I think with that, we'll kind of sign off here. I'll just wrap it up. So again, really thanks for everybody's attention and taking time out of your day to attend the webinar here, learn a little bit more about the approach for DFR. My colleague, actually, Daniel Jenkins, he's going to be doing a similar webinar on July 25th. And that's going to be focused more on the utilities and kind of commercial side with Part 107 waivers. So if you're interested in learning about that as well, you're welcome to mark that on the calendar. Again, that's July 25th. Also got to note that the recording is going to be available afterwards, and that'll get sent out. And so I think to kind of wrap up the day, we're just going to play maybe one last video to wrap up the webinar. So again, thanks for everybody for joining, and we'll see you on the next one.
It's been 6 months since we shipped our first X10s. A lot of those drones are going to public safety customers. So I wanted to give everyone an update on what's happening in the market. We're at just an incredibly exciting time for drones in public safety. The impact is phenomenal, and now we're seeing the scale and scope of deployments get to another level. We're seeing agencies like Las Vegas Metro Police Department lean into the patrol-led model, where they're putting drones in the trunks of more vehicles so they can be available on more scenes. We're seeing NYPD do full drone as first responder, with Skydio drones flying out of docks autonomously in response to 911 calls. We're seeing just incredible stuff on a daily basis from all of our customers having life-saving impact with drones. So we've got a lot of great product out there in the wild now. I want to give you an update on what's coming next from a product perspective. We're about to ship our Spotlight accessory, which pairs beautifully with NightSense to give the drone and the operator perfect visibility in zero light environments by illuminating the scene so you can see exactly what you need to see, even at night, even in zero light environments. Later this summer, we're going to ship our speaker and microphone accessory, which gives you bi-directional communication to help de-escalate the most dangerous situations. And then on top of all of this, we're doing more with the lights that are already built into X10. So you'll be able to configure them to do the flashing red and blues, just like you see on a police car, as well as strobe for better aviation safety. Skydio drones have always had the ability to do live streaming, but now we're taking it to the next level with ReadyLink. ReadyLink makes it super easy for the pilot or the operator to create a link and share that live stream with whoever needs it instantly. You just create the link, you can use a QR code, you send it out, and everybody on your team instantly gets access to that same live stream data. Another area where we've invested quite a bit is on our integrations. So we have APIs that make it possible to get geospatial data from other systems into Skydio Cloud. This enables you to do things like get real-time CAD events, location of 911 calls coming in, along with the location of other officers, maybe from their body camera. And then on top of this, we're adding a feature we call Fly Here Now, which does exactly what it sounds like. It just sends the drone to that location. And this means that you can dispatch drones to the incoming location of calls or to the location of responding officers. One of the features that I'm most excited about that our team built is this side-by-side view with a 3D map that's oriented with the same point of view with the drone's camera. So this gives you the ability to see street names as well as other augmented reality information like the location of that call or the location of that officer right alongside the live feed, which takes situational awareness just up to that next level. As I mentioned, we already have customers doing dock-based operations in public safety, but the thing that's really going to complete this story is the dock for X10, which I am touching right now. You can't see it, but it's coming later this year. So look, it's a super exciting time for the market, and we know there are competing solutions out there. It's no secret that DJI makes really good hardware, and there's other companies that have tried to Frankenstein together a DFR solution on top of DJI drones. But at their core, DJI drones are designed to be manually flown. One of the things that we think is really important for a successful DFR program to reach scale is autonomy, which is of course something we bet really big on at Skydio and we continue to lead the way on. But another concept that we're finding to be increasingly important is the tight integration of the hardware and the software to run a DFR program. So we designed the drones, the docks, the autonomy software running on board, the connectivity, the cloud streaming, the management, all of these things together to work seamlessly, which generally makes it easier for our customers to adopt and scale. Of course, DFR programs don't stand alone. And the other thing that we focused on is partnering with the leading public safety technology company out there, Axon, to deliver the complete solution. We generally think about drones being the spoke that you want to plug into your existing information hub. We've got a lot of great hardware and software out there today. As you heard about, there's more coming down the pipeline, and there's a lot more behind that. But at the end of the day, the technology isn't what matters most. What matters is the impact this stuff is actually having. And it is such an honor for us to get to partner and work closely with agencies that are deploying this technology on a daily basis to help save lives, help protect their communities, help keep everybody safer. And that's the journey that we're on with you.